Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you today about OR and probabilities. In this app, you'll learn how to calculate probability problems that involve the word OR. For example, when considering the experiment of rolling a six-sided dice, you will be able to calculate the probability of rolling an even number or rolling a prime number. We'll also learn how to calculate AND probabilities. This would be, for example, when rolling two six-sided dice, we could be able to calculate the probability of rolling an even number on the first roll and rolling a prime number on the second roll. To calculate OR probabilities, that is the probability that event A or event B occurs, we'll use the following formula. This is the probability of event A plus the probability of event B minus the probability that event A and B occur. I think it should be noted that even though we have this formula, a lot of our probability questions can still be calculated using just that fundamental definition of probability that we learned in the previous presentation. This subtraction of the probability of A and B is removing the double counts. If you think back to that definition of probability, when we calculate the probability of event A, we have to count how many times could A occur, and when we count the probability of event B, we have to say how many ways, how many times could event B occur, and then this A and B. Well, we've already counted those, right? They're somewhere in here when A and B both occur. We've counted them. Excuse me. We've counted them twice. Okay. So the removal here of the probability of A and B, that's making us only count each outcome one time. Let's take a look at an example. Say we have pieces of paper numbered 1 through 12. Those numbers have been put into a hat. A single number will be drawn from that hat. We want to find the probability of selecting a number less than 8 or an even number. To calculate this, again, following the formula, we would say we'll find the probability of selecting a number less than 8 plus the probability of selecting an even number, and then we'll take away the probability of selecting a number less than 8 that's also even. And when we do that, we'll see that there's 7 of the 12 numbers that are less than 8, so the probability of selecting a number less than 8, 7/12, plus there are 6 even numbers when we think about the numbers from 1 to 12. And then we'll take away the 3 of those that are both less than 8 and even. 3 out of the 12 is the probability of that. And so we'll finally get 5, 6 as our reduced probability. You should probably pause and try this problem, this first part, just using the definition of probability. You'll find that you can count these things and you should come up with 5, 6 the same way. If you abandon this formula and just say, how many ways could I get a number that fits this description? Let's talk about calculating AND probabilities. When we talk about these AND probabilities, we are talking about the probability of event A and event B occurring. And that formula is given by the product of the probability of event A and the probability of event B. It's very important to note that this formula assumes that when we multiply by the probability of B, that we're calculating that probability under the assumption that event A has occurred. This is technically called conditional probability. However, conditional probability is not part of our course. so we just insert this as a clause here. So again, when we go to calculate the second probability in this product, we always assume that the first outcome, the first event, has already occurred. Let's take a look at an example. Consider the experiment of drawing 2 cards from a 52 card deck of cards. We want to find the probability of the following. Probability of selecting an ace on the first card and a king on the second card. And this will be if the cards are drawn without replacement. This language of without replacement is indicating that we select the card and we aren't putting it back into the deck. Once we remove a card, it's out. Part B will be finding the probability of selecting an ace on the first card, the first draw, and a king on the second draw. In this case, we're going to be selecting with replacement. In part C, we're going to find the probability of selecting an ace and a king if the cards are drawn without replacement. In part D, we're going to find the probability of selecting 2 aces if the cards are drawn without replacement. For part A, we're finding the probability of ace on the first and king on the second. There are 4 aces out of the 52, and so our probability of selecting an ace is 4 out of 52. The probability of selecting a king on the second draw is 4 out of 51. And again, it's out of 51 because we were drawing without replacement in part A. So there are no longer 52 cards, there are 51 cards in the deck. All right, and that reduces down to be 4 out of 663. Part B, we're finding the probability of an ace on the first draw and a king on the second. There are 4 aces in the deck of 52 cards, so that probability of selecting an ace is 4 out of 52. And there are 4 kings in the deck. And in the part B, we were selecting with replacement, so there are still 52 cards in the deck when we go to select the king. And so this is 4 out of 52 times 4 out of 52. Resulting in 1 out of 169. In part C, we could either draw an ace on the first draw and then a king on the second, or a king on the first draw and then an ace on the second. So in this problem, we actually have two separate scenarios to consider. The first scenario is going to be that we draw an ace first. So the probability of drawing an ace on the first draw is 4 out of 52. 4 aces in the deck out of the 52 cards. And we're going to multiply that by the probability of selecting a king, given that we've already selected a card, selected the ace. So that's 4 out of 51. We're going to add to that the scenario where we draw a king on the first draw. So there's 4 kings in the deck. There's 52 cards. And then again, once we've drawn the card, there's only 51 cards left in the deck. So 4 aces out of the 51 cards, this is our probability of selecting an ace on the second draw, given that we've already selected a king. Multiplying and summing these up results in 8 out of 663. You will notice that is double part A. Okay, double part A, as it should be. Part D, we're going to find the probability of drawing 2 aces. This is probability of ace on the first draw and ace on the second. And that is 4 aces out of 52 to find the probability of selecting an ace. And in part D, we're drawing without replacement. So when we go to select our second card, there are only 3 aces in the deck of cards because we did not put the ace that we drew on the first draw back. And there are only 51 cards, so the probability of drawing an ace on the second draw is 3 out of 51. The product of those is 1 out of 221.